I wouldn't let that happen.
We don't want you ending up like Trump, basically.
As if.
All right, let's look at this. What is going on? Kim has decided to save all of her allowance for the next 3 years. If she gets $20 each month, she's going to deposit it into some account. How much money will she have saved up at the end of the 3 years? Which one do we use?
Future value?
Future value. So this is the future value one. Okay, the way you distinguish them is if it's to the power of negative something, and that's going to be present. This one's the future value. So what's R?
20?
Yeah, R is 20, right? What is I? So I is going to be, you tell me, what's I going to be?
Do I divide it by 12?
Yeah.
Like, okay. 0.283?
So you divide 0.035 by 12, right?
Oh,
0.035, because you got to take it into a decimal first.
0.0029.
Yeah, and then you can just add that with the 1, yeah, to the power of n. What's n? It's being compounded monthly, and she's depositing it at every 3 years, every month for 3 years. So it's the n value.
36.
Yeah, 36 minus 1, and all over the I value 0.0029. All right, you've done this a lot of times. Tell me the final answer here. Oh, you got to use the STO1 and RCL1 if you want the exact value.
Okay.
Actually, for this one, do you even need to use STO? I don't think so. You can just first plug this bracket, this entire square bracket, and you can either multiply by 20 first and then divide by the denominator, or you can divide first and then multiply. You don't need STO RCL here. That's if the left-hand side is missing. That's if it turns into an equation.
Okay, is it 757.77?
That's exactly right. Is this person going to make money from the bank, or is she going to have to pay them?
Make money?
How much money does she make over 3 years?
Like how much interest she earned?
Yeah, yeah. So what do we need to subtract this from by, I guess? She's gonna pay 20
she
bucks.
made 37.77.
Yeah, there you go. That's the final answer. And one and done. Okay, easy as that. It's not that hard. What about this?
Do I just like multiply everything?
So which one do you use? 1, 2, 3, or 4?
1.
1, right? So interest is P. What's P here? P is the amount.
8,000.
Exactly. What's R?
0.8.
0.08. What's T?
5.
5. Yeah, you multiply all of these guys. You get 3,200, yeah?
Mm-hmm.
So this is the interest that he made. And then you can add this with the initial amount using this formula to find the final amount, which they're not asking us. But how much is in the bank after 5 years? So it's going to be 8,000 plus 3,200, which is, what's that, 12,200? Yeah. 11,000, sorry, not 12, 11,200, and you're done.
Okay.
So that was a simple interest. Okay, Chris took out a loan to buy a snowboard. He has agreed to pay $600 in 2 years. How much would he need to pay now to buy the snowboard instead of taking out a loan? So 1, 2, 3, or 4.
2.
4? What? Sorry, say that again.
2.
2. Okay. So what's given? APIN.
I is 0.005.
Okay. What else?
N is 24.
2 times 12. Yeah, 24. What about between A and P? Is 600 your A or is it P?
A is 600.
Yeah, that's right. A is 600. And you're trying to find P, yeah?
Mm-hmm.
So we have 600 is equals to P, 1 plus I, so 1.005 to the power of 24. How do you solve this equation for P? So this is an actual equation, right? We're not just trying to find the right-hand side. What you want to do is first do this. And then you want to store that. And then the next step would be, you want to divide both sides by that. So you do 600 divided by recall 1. Try that.
532.31.
Yeah, that's right. So 532.31. And this is the amount to date. Okay. This is what the snowboard is worth today. How much did he end up paying in interest?
Do you just subtract that from 600?
That's exactly what you do. Yeah. So you get 67.1 to the nearest cent, which means 2 decimals.
69.
Yeah, and you're done. Okay, 67.69, and you are 1 and done. Easy. So she won some money playing bingo. People earn money and decided to invest 3,000 into a bank that earns 6% compounded quarterly. How much will Lorena have in the bank if she leaves the money there for 5 years?
You use the second one?
Yeah, you'd use the second one. So what do we know? APIN.
N is 20 and I is 0.015.
Yeah. What about between A and P?
P is 3,000.
That's right. Yeah, P is 3,000, sorry, not A. P is 3,000 and we're trying to find A. So it's a basic plug and chug. Do we need to use a RCL or a STO for this question?
No.
No, we don't, because we have everything, right? We have everything that we need. Cool.
Uh-huh.
So we'll just plug it in. 3,000 times 1.015 to the power 20. Try plugging this in.
Um, 4040.56.
There you go. So he made an interest of, again, you can just subtract this in your head because you're just multiplying that, right? So this is the interest he made over 5 years, which is a decent chunk, right? It's a decent amount. Any interest is good interest, I guess. Eventually, I don't know if we'll ever do it because it gets pretty advanced, but there is a way that you can maximize your interest. You can do some maths to see which one actually pays you or how much yada yada. Like there's a lot of variables to take into account that you'll do if you go into like in university, if you go into like a business program or accounting program or something. For us, we're just gonna touch base on it. We'll see where we end up. But yeah, there's a way you can take all of these variables into account and find the most optimum way, because there's a lot of paths here. Even if you look at the same bank, even if you keep one of the variables constant, there are other variables you need to take into account, and there is always the best path. But then you'd have to sacrifice something for it. Usually it's going to be convenience. Like if you take the path that gives you the maximum interest, what usually happens is that your money that you have in this account, let's say you have 850, you won't be able to touch it for how many years? Okay.
Mm-hmm.
But a lot of people, they put a lot of money, or their entire life savings, they put into this to maximize the interest. But now they're stuck. It's this money is in the bank. You cannot take it out for 5 years. So what if you need it today? Then what, right? So is this the best way? I guess that's subjective. You could take it out. This is very weird. Like you could take it out, let's say after 2 years, but then the money that they would have paid you, you're gonna have to pay them back as fees for dropping out of the contract before the end date. So you got to take into account those things as well. Okay, what's going on here? Gail won the lottery and decided to put all of it in the bank. She plans to make regular withdrawals of $850 every 3 months for the next 20 years. Interest is compounded 3.5 quarterly. How much did Gail win in the lottery? What kind of a problem is this?
Present value.
Yeah, this is present value. So what do we know?
The present value is unknown.
The present value is unknown, yeah. That's how much he won today.
R is 850.
Yes.
And I is 0.0087.
Yeah, 0.00875 is your I. What about N?
Oh, N is 80.
Yeah, that's right. Let's spice this question up a bit. All right, so he's gonna put his money in the bank for the next 200 months. Okay, he's putting it for the next not 20 years, he's putting it for the next 200 months. Now tell me what I is gonna stay the same, I guess, 0.00875. What is your actual N value?
Um,
Is it 800?
no.
No, it's not 800. So what is it?
Do you have to like convert it into years?
Yes, you do. Convert it into years first and then do the quarterly.
Is it 2.19?
No.
No, okay. Do I divide 200 by 265?
Okay, that will take you to what? No, here's how you do unit conversions of it. You don't divide by 365 because it's not 200 days. You see, you have months, yeah? You need to convert this into years, right? First, quarterly is ×4. That comes at the end. First, you need to convert this into years. So introduce a new variable, years, in the top, okay? And then you see there's a month here. We need to cancel out this month. Just treat it as like X, okay? Treat it like X. Now, what's the conversion factor between years to months? In 1 year, you have 12 months, right?
Mm-hmm.
So you see the months cancel out. So you actually divide it by 12 to take it into years.
Oh, okay.
If you divide by 365, that's going to give you nothing. You could first turn it into days by multiplying by 30 and then divide by 365. That will also give you years. But as is right now, months into years, you divide by 12 first. And because it's being done quarterly, whatever you get there, you multiply that with a 4.
Okay.
Gives you something like 66.6667, right?
Mm-hmm.
So we have present value equals 850. And then we have 1 minus 1.00875 to the power of negative this all over 0.00875. Try plugging this in your calc.
Um, 42,796.02.
Yeah, there you go. That's how much they earned in the lottery, which is a very, very specific number. Now, how does that work? I have no idea. That's not a lot to win to begin with, right? I mean, it's still something. $40,000 is still a lot of money, to be honest. It'll pay for your university completely, unless you plan to live in the res. Double check this. Okay, whatever. Yeah. So decent chunk. Here's something about lottery, which is good in Canada, which is not good in the US. In Canada, you don't pay tax on lottery winnings. What does that mean? If they advertise something for 20 million, you win this, 20 million in your bank. Okay?
Keep all of it?
You keep all of it. But in other countries, such as the US, you'll won 20 million, you'll probably pay what, 5-6 million, depending on the state in taxes. And they use states instead of provinces. And then you keep whatever's left. So you have to pay the government a portion of your tax and lottery winnings. Which is, yeah, do they deserve it? I mean, you are the one who got lucky. I don't know. That's an ethical question, but it's better to win a lottery here than it is there. I mean, it's better to win a lottery anywhere. Tax me, give me the lottery, tax me. Okay. But the likelihood of winning a lottery is like astronomically small, unfortunately. Okay, that was not Let me just keep this here. Let's start from the bottom up, because the hardest questions are always at the tail end. Okay, here, what's going on? What kind of a question is this? She's making $50 payments every 2 weeks, compounded 6% bi-weekly. If she will need to make 40 payments, what is the cost of her trip?
Future value.
That's right, future value. So it's that one. So what do we know? FV, R, I, and N.
FC is the unknown.
Yeah,
And R is 50.
that's right.
Bi-weekly is it like 26?
It is.
So I is 0.0023.
Yeah.
And N is it just 2 weeks or?
N is 2? No. What is the definition of N? N is the number of compounding periods, which is just a fancy way of saying payments.
Oh,
She'll make 40 payments. That means her thing is gonna go through 40 different compounding periods. N is 40.
okay.
Okay. So in this question, we didn't have years, we didn't have nothing, but they did give us a number of payments, which is going to be our N. Okay. So we have FV equals R 50, 1.0023 to the power of 40 minus 1 divided by 0.0023. Plug it in and tell me what you get. We don't need to do any of the store recall things here.
2092.36.
Okay, round it to the second decimal, right? 37. Round to the nearest cent.
Okay.
Wait a sec, that didn't, they're saying it's wrong. They got 1908. How does that work? Wait a sec. Did we plug something in wrong? Okay, what could have happened? There's only one thing that could have happened here. What do you think that is? Because we didn't get what they got. We're off by about 100. If you can identify that, I'll give you 10 points. There's only one thing that could have gone wrong. You see the I value, right? It's not 0.0023 here. Well, it was something else, right? It went all the way there. So we didn't take that into account, which gave us a little bit of a different answer than what they got, okay?
Okay.
So even small things make a big difference. That's why maybe we should have used that. Let's see. Well, we're gonna get this one to the dot. So for that one, we could have just done store and recall and we would have gone it. Let's see this. After how many weeks will 300 amount to this if it earns this interest? So what kind of a question is this? 1, 2, 3, or 4?
One.
It's 1. It doesn't say if it's simple interest or anything, to be honest.
So 2.
This it's unclear. It should have said what it is. Let's do it's 2. Let's assume it's compound interest.
Okay.
Yeah, it doesn't say anything. It just says per annum, so that could be either 1 or 2. We're gonna make things difficult for ourselves, so we're gonna say it's 2. So what do we know here?
A is 345.
Yeah.
P is 300.
Right?
I is 0.0354. And N is unknown.
Right, so let's set this up. So 345 is equals to 300, 1.0354 to the power of n. How do we solve this for n?
You divide by 300.
Okay, so 345 divided by 300, that is 1.15. What's next?
You use log.
Right, so if you use log, what do we get?
4.017.
Yeah, 4.017 is n. Is that the number of weeks? No, that's n. What does n mean? That's the number of years. Okay,
Oh,
how do we convert this into weeks? How many weeks are there in 4.017 years? How many weeks are there in 1 year?
52.
Yeah, so just multiply that by 52. And you should get the final answer in terms of the number of weeks. Okay.
208.8.
Well, this is assuming that this is compound interest. It doesn't say, so we're just gonna make things difficult. It is compound interest. Okay, let's look at this one. How much more interest is earned on a $5,000 investment for 3 years if it earns 2.5% compounded semi-annually instead of 2.5 compounded annually? How much extra interest is earned? Okay. So 1, 2, 3, or 4.
2.
Yeah, it's 2. So we're gonna have to do this 2 different times. So we're gonna find the interest when it's semi-annually, and then we're gonna find the interest annually, and we're gonna subtract one from the other. Okay. So what do we know for semi-annually? What's API and N?
P is 5,000.
Right.
I is 0.00096.
Where'd you get that from? What'd you do to 2.5? Did you divide by 26? No, semi-annually. That you did bi-weekly, right?
Oh, okay. So
Semi-annually.
just 2.
just 2, yeah, divided by 2. 0.0125. What do we do with the n? N is 3 years, but what do we do with it?
You get 6.
Yeah, you get 6, and then our final amount A is missing. So A is gonna be 5,000, 1.0125, just add them up to the power 6. So plus 1 to the power 6 times 5,000. That gives me 5386.92. How do we find the interest?
You subtract.
Yes, you subtract. So can you do this in your head? 5386.92 minus 5,000.
386.92.
Right, 386.92. That's the interest. Now let's look at the other guy, the annually. What do we know about this part? What's
P
AP?
is 5,000.
Yeah.
I is 0.025. N is 3.
Yeah, an amount is missing. Prediction. Is it going to earn more interest or less interest compared to semi?
Less.
Yeah, why?
Because you earn more interest as much as you compound it.
Yeah, that's right, because you earn interest for the interest that you compounded. So let's see how much the difference is. Shouldn't be that significant, but we'll see. So 5,000 times 1.025 to the power 3. 0.025 to the power 3, and that gives me 5384.45. So the interest here is 384.45, right? What's the final answer in this question?
You subtract the 2.
Yeah, you subtract the 2, and even though it's not much, right? It's not much. 1's still 1, right? 386.92 minus 384.45, and that gives us 32.47. Nope, that is completely wrong. What did I do? That should have been 2.47. Sorry. $2.47. Okay.
Okay.
Yeah, not a lot though, not a lot. But still, you would choose this one if you can over the other one. Alrighty, this one. Determine the principal needed to earn $50 in interest at this simple interest in 46 months. One, two, three, or 4.
1.
1. Okay, so what do we know? We have I, P, R, T.
I is 50.
Yeah.
P is the unknown.
Mhm.
Do I have to convert the rate
To what?
like a decimal?
Yeah, always convert percent into decimal. What's 6.3, 6 3/4 improper fraction, right? Mixed fraction, sorry. That into a decimal.
Do I have to turn it into a proper fraction first? Or
What's 3/4 as a decimal? 3/4, 3/4 into decimals.
like 0.75?
Yeah, so 6.75% is what that is, right? To convert it into decimals, just divide this by 100. 0.0675.
Mm-hmm.
Yeah, you don't have to turn it into a proper fraction. That's it. Okay, now this is a tricky bit. What's our t? Is it 46?
No.
What do we need to do with the 46?
Do you divide it by 12?
Yeah, that's right. You divided it by 12. What's 46 over 12?
3.8.
Exactly. Okay. What's next? It's 3.8333, okay?
Mm-hmm.
So let's look at the equation. So we're using this one, right? I, so 50 is equals to P, we don't know that what that is, times 0.0675, and then we know the T is 3.8333. How do we solve this equation for P? It's a simple linear equation.
You divide
By what?
the other two numbers.
Right, so 50 divided by 0.0675, that gives me some number, and I'm going to use that. I don't know if, yeah, you definitely do to, no, you don't, right? You just, why don't you try this? Do 50 over this first, and whatever you get, do that over this. You don't need to do the STORCL, I don't think.
Um, 193.24.
Yeah, so there you go, that's the principal, 193.24, okay? What's the final amount after 46 months? How much is in the bank?
Um, do you subtract 50?
What's the final amount? Look up there. We found P, right?
Mm-hmm.
Found P, they've given us the interest. We put in P, we earn the interest. What's the final amount? What do we do? Do we add or subtract here?
You add it.
You add it, exactly. 193 plus 50 in your head, what is it?
Um,
There's a calculator if you have to. 19 plus 5 is 24, right? So 193 plus 50 would be 243, and then the decimal. And there you go, that's the final amount.
okay.
Okay, so there's $243, which is not a lot, actually. Well, you only earned $50 over almost 4 years, so simple interest is not the best. Well, it's the best if you can loan money, because then you pay less interest. But no bank really allows you to borrow money in simple interest. It's almost always compound interest. And worse than that, it's gonna be compounded daily, unfortunately for you, if you borrow money from the bank. Which is why the interest rates are so high right now. Well, not the interest rate, like how much you end up paying interest when you buy a house or something. Like you end up paying like hundreds of thousands of dollars over 20 years, 25 years. It's because the interest there is being compounded daily, okay? Even though you pay a monthly mortgage. Anyways, let's look at this.
2.
2, that's right. So what do we know?
A is 2,500.
Yeah.
E is the unknown.
Mm.
I is 0.1555.
Okay.
And
0.0155.
N is 40.
Yeah, N is 40. So we have 2,500 is equals to P 1.01555 to the power of 40. Tell me what P is. It's just a 2-step on the K. It's just a 1-step if you know what you're doing.
0.54.
What's happened? Is that the principal?
I don't think so.
No, that's not right. So you just do this, right? 2,500 divided by 1.015555 to the power of 40 on the calculator. Because we just need to divide both sides by this to get the principal.
Mhm.
Try it. 2,500 divided by that thing to the power of 40.
Oh, 1,348.35.
Okay, yeah, that's right. Okay, advanced strats. Advanced strategies. What does that mean? Here, we're gonna try and find the exact answer, but you're gonna have to bear with me here, okay? We know our interest rate is 0.0622, okay? And we know it's being compounded quarterly. Do not convert this, all right? Do not convert this. So what does it look like? It looks like 2,500 equals P1 plus I 0.0622 divided by 4, right? To the power of 40. Try this. This will give you the exact answer. 2,500 divided by 1 plus 0.0622 divided by 4 to the power of 40. Because we had like a irrational number there where it kept on continuing, which is not irrational number, but recurring number.
1,348.61.
Yeah. So 1,348.61 is the principal amount that you have to put in today, so that in 10 years it becomes 2,500. Okay. This is more realistic. I don't know. That's not really. Is it 6.22? It's I would say, because you only earn like $1,000 over 10 years, which is more realistic than a lot of these interest rates they throw at us. This one's gonna be realistic because when you have to borrow money, it's realistic, but when they have to give you money, it's unrealistic. 1, 2, 3, or 4. Which one is this?
2.
Okay, so what do we know? A, P, I, N.
A is 12,500.
Okay, first of all, this is not 2. How do I know it's not 2?
Oh, it's
Monthly
present
payment.
value.
That's present value. It's gonna be 3, right? So just call that PV. So present value is 12,500. What's R? What's I? What's N?
R is unknown.
Yeah.
I is 0.004. And N is 36.
Okay, N is 36. That's right. What about I? What did you say I was?
0.004.
You divided by 12, right?
Uh-huh.
Okay, yeah, that's right. So see, that one gave you the exact number, right? There were no any decimals left behind. So that one we're gonna write it as this. But let's say it didn't give you that. It gave you 0.0004444 for whatever. Then we would do would leave it in the fractional form, okay? Because we want the exact answer. So we're trying to find R. So present value 12,500 equals R. And then we have present value is number 4. 1 minus 1.004 to the power of negative 36 divided by 0.004. There we go. What do we do here to find R?
Do the bracket first.
Okay, do it. and then do the division. And this one you have to use STO RCL because there's two parts to this equation. So first do the main bracket, the
Is it
numerator. Yeah, go ahead.
373.51?
That's exactly right. That's the exact answer, which is what we want. Yeah,
Uh-huh.
there we go. 373.51.
Okay.
Can you tell me how much interest did she pay over 3 years?
Do I subtract that from 12,500?
Just 373? No, you do subtract. You're gonna subtract 12,500 from something. So she's paying this amount, right? How
Mhm.
often does she pay it? She pays it 12 times a year. How many years? 3 years. There you go. You do this minus 12,500.
Oh, okay. $946.
Yeah. And that's the interest she pays, which is okay, I guess. Over 3 years, $1,000 for a car isn't that bad. That was 8. Okay, what about this one?
Future value?
Yeah, that's right, because we want 8,000 after that, right? So future value is 8,000. What is I and R?
I is 0.29.
Okay, what did you do wrong? It's not 0.29.
0.029?
Yeah, 0.0. That's gonna make a big difference. What about N?
14.
Yeah. And R is missing. So let's plug in the formula. 8,000 equals R missing 1.029 to the power of 14 minus 1 all over 0.029. All right. First, again, we've done this many times now. First, do this bracket bit. You're gonna get something. Whatever you get, you're gonna divide it by the denominator.
Mhm.
And then you're gonna do STO1. And then for the last step, you're gonna do 8,000 divided by recall 1.
$471.39.
And number 7. Yeah, there we go. You see, 471.39. 1 and done. Okay. Easy as that. Here, let me give you a question. You borrowed today. You borrowed $10,000 today. Okay. Today.
Mhm.
And this gives you a monthly recurring payment monthly. It pays you, or you have to pay them monthly. You have to pay them how much? I don't know, $500. Let's use nice numbers. The interest rate is what's another nice number? 7.5%. Okay. The question is, how many years? After how many years did you fulfill the obligation, or did you pay off the loan? So what kind of a problem is this? You borrowed $10,000 today for a car, or you finance it. Monthly recurring payment is 500. The interest rate is 7.5% per year. After how many years did you pay off the loan?
Is this present value?
It is present value. So what do we know?
The present value is 10,000.
Yes.
R is 500.
Yeah. Make this
R is
7.2.
0.075. Oh,
Okay, we're just gonna make this because that's gonna give us a nice number, I think.
0.072.
No, it's being monthly payment, right? Monthly payment. What do you do? That's the interest rate per year.
Oh, so do I divide it by 12?
Yes.
Oh, okay. Zero point zero zero six.
Yeah. What about your N?
12M.
Yes. So now let's use the formula. So we have 10,000 equals R, which is 500. And then we have 1 minus 1.006 to the power of negative 12n all over 0.006. There we go. So now we have an exponential equation to solve because the unknown is in the n up there. What's the first step?
You divide by 500 and get 20.
Okay, yeah. And then?
Do you do the bracket first?
You can't do the bracket first because there's nothing you can do because there's an unknown there. What about the denominator, 0.006? Can you do anything with
You
that?
multiply?
Yeah, you multiply that on both sides. So 20 times 0.006. That gives you 0.12, right? 0.12. Now what do you do? Is the question. You can get rid of the bracket because as doesn't change anything.
You add 1.
You add 1? No.
You subtract.
Yeah, because if you add 1, you'll get 1.12 here. You'll get 2 minus something there. You subtract 1. So this cancels out with this. 0.12 minus 1 is negative 0.88 equals negative 1.006 to the power of negative 12n. What's next?
And then you do log and bring the exponent down.
You see there's a negative sign on both sides. Can we do anything with this?
They cancel out.
They cancel out, exactly. And then you do logs, right?
Mhm.
You'll get log of 0.88 is equals to negative 12n log of 1.006. Now what?
You divide by log.
Okay, so log of log of 0.88 divided by log of 1.006. That is negative 21.369 equals negative 12n. What now?
Then you divide by 12.
Yeah,
Negative
negative 12. So you get n is equals to 1.78 years or weeks or months.
Years.
Exactly, and that's the final answer, okay?
Okay.
How much interest did you pay them?
You multiply 500 by 12 and then by 1.78.
Yeah. And what do you do with this? That's going to be the amount you paid them. How do you find the interest using that?
You subtract that from 10,000.
Yeah, you subtract 10,000 from this and you will get $680. So you paid $680 in interest or whatever this is. Okay,
Okay.
that makes sense?
Mm-hmm.
Okay, here's another question. I'm gonna have to make one up. Let's say after 3 years, okay,
Uh-huh.
interest rate is something nice, 4.8%, compounded quarterly, okay, compounded quarterly. Actually, it has to be, no, never mind. I'm trying to make interest that's missing. So let's say amount, future value is $1,000. UR is 200, okay.
Mm-hmm.
I is missing, but it's compounded annually, okay. And N is 1. This is the future value. How do we find I? So we have 1,000 equals 200. 1 plus I, we don't know what I is, but we know it's being compounded annually. 1 plus I to the power of 1 minus 1 all over I. How do we solve this equation for I?
Use decimals.
Use Desmos? No, you can do this by hand.
First, you divide by 200.
Okay, you'll get 5. Multiply the unknown on both sides, the denominator on both sides. You see the I here?
Mm-hmm.
It's gonna go up. This is only gonna work if N is 1, you see? Otherwise it doesn't work. So divide I on both sides, this is gone, which means we can also kill off this bracket. And to the power of 1 doesn't mean anything. You can just do that. There we go. How do we solve this for I?
You add 1.
Okay, 5I plus 1 equals 1 plus I, and then?
Do you have to bring the i's on one side?
Yeah. So what does it become? Well, this question is, so bring this to this side, bring this side, okay? So get 4I equals 0, I is equals 0.
It's just 0.
It's just 0, yeah. So there you've not earned any interests, basically, that's what that means.
Oh, okay.
Okay, which can happen, right? Which can happen if you deposit 205 times or 6 times, whatever, over a year, you don't earn any interest. Well, it does if that's if you pay to your friends or something, not to a banking system. But this is the only time where you can do this by hand. Also, you can also do the I square by hand, but then you'd need to use the quadratic formula. I don't know if you remember that. See this exponent here? This is 1 or 2, you can do it. If it's 3 or above, then yeah, it's gonna be tricky. You're gonna have to use technology to do it. Okay.
Okay.
All right, let's call it a day.
All right. Thank you.
Bye-bye.